we have to determine whether the series is absolutely convergent or conditionally convergent. So first we check for absolute convergence, because absolute convergence implies convergence. Now, if when we're checking for absolute convergence, we find that it diverges, it doesn't actually mean that the entire series diverges. It just means we must now check for conditional convergence or actual divergence with another test. So let's check for absolute convergence first. We have a series with a sub n, and we say that this series has absolute convergence if this converges. So let's go ahead and make that substitution for a sub n. So that would be sine of n over 2 to the power of n. Now we can check for convergence or divergence. A good method would probably be to use a comparison test. A comparison test is always a good idea because those tend to be quick if you can execute them. So first of all, let's apply the absolute value. When we apply the absolute value, we would get sine of n, and then we would get 2 to the power of n because that's going to be positive anyway. But with the absolute value of sine of n, it does make a difference because remember, with sine, which is a wave like this, we do get negative values out from that when we start plugging integers into n. So with the absolute value, what that changes is that we can no longer get this negative stuff down there. We can only get from 1, because this sine is always under 1, we can only get from 0 to 1, right? So we're always going to get values which are less than 1. So our comparison test could be this. This is going to be less than 1 over 2 to the n. The denominator we leave the same when we're doing the comparison. And this right here, you might notice, is a geometric series. Because when we take 1 to the power of n, that's just 1. So we could write it in this form, rewrite it in a form in which we can see what the common ratio r is. R equals 1/2. And remember, when the absolute value of r is less than 1, then it converges. And in this case, it is less than 1. So that's telling us that this converges, and since this series is less than that series, this series must also converge. Since we're doing the absolute value of this series, it absolutely converges. Absolutely converges.